So folks, in this video what I want to do is learn how to multiply a matrix row vector to a matrix column vector. So it turns out that the process of matrix multiplication, which we've been alluding to, is really just a sequence of row and column vector multiplications. This procedure is going to seem very familiar for those of you who have done some work with vectors before, where this calculation is mathematically exactly the same as computing the dot product of two vectors of equal length. So let's go ahead and multiply together. Let's say matrix A is the matrix 1, 2, 3, and matrix B is the matrix negative 2, 0, 3. So this is a row vector, as we mentioned last time, and this is a column vector. And something to note is that this is a 1 by 3 row vector, and this is a 3 by 1 column vector, and so they have this has the same number of columns as this has rows. And when that's the case, we can define this multiplication. So A times B. Notice I'm not going to put any operator in between there. So when we know that A is a matrix because it's a capital letter, and we know that B is a matrix because it's a capital letter. And so I'm saying how to multiply A times B together, and that's going to be done this way. We're going to take, here's the matrix 1, 2, 3, and we're going to multiply it to the matrix negative 2, 0, 3. And it turns out that this is going to give us a 1 by 1 matrix. That'll be the answer to this. It's a 1 by 1 matrix. Another way to think about it is it's just a number, but it's a 1 by 1 matrix. And what I'm going to do is I'm going to take 1 times negative 2. That is, I multiplied the first entry in this row vector to the first entry in this column vector. Then we're going to add that to 2 times 0 plus 3 times 3. So the next thing we did was we took this second entry in the row vector and we multiplied it to the second entry in the column vector. And then last we took the third entry in the row vector times the third entry in the column vector. And we just double underline that one. So that's that 3 there, that's that 3 there. So this is, if you notice, I'm multiplying entries together and then summing them up. So for those of you that have learned the dot product of two vectors, that's exactly what you did when you computed the dot product. Let's go ahead and simplify this. Let's see here. This would simplify to negative 2 plus 0 plus 9, or that comes out to be 7. And in this case, I want you to think about this. This is the number 7, but we could also think about it as the 1 by 1 matrix 7. Okay. So that's how we multiply a row vector to a column vector. Now I want to stress something, that if I were to ask you to do matrix B times matrix A, that this is a column vector and this is a row vector, and this multiplication is not defined. So this is how this is actually different from what we think of as the traditional dot product. In this case, the multiplication is not defined. So all I've defined how to do is how to multiply a row vector to a column vector. And as you remember in one of the original videos, I said multiplication is not commutative generally, and I cannot multiply this column vector on the left to this row vector on the right. That multiplication is not defined. Alright, we'll pick this up in the next video.